Hi, welcome to part 2 in the easy subnetting series. This week we're going to talk about hexadecimal. So sometime in the late 60s, computers got big enough that engineers were able to change from a 3-digit system to a 4-digit system to allow for more combinations. And that's where hexadecimal was born. So that's how old this stuff is, from the 60s. Alright, hex uses a 4-bit value called a nibble, sometimes spelled with a Y, and 2 nibbles make a byte. And that's how it kind of all works together. So there's what a nibble looks like, 1010, just 4 bits. And then we already talked about byte last week. So a hex digit can be one of 16 possible combinations, 0, 1 through 15. But in order to keep the bits as a single digit, any double digit number like 10 and 11 were changed to a letter. So it goes 0, 1 through 9. And then instead of 10, we have A, 11 is B, C is 12, D is 13, E is 14, and F is 15. All right. So now, hex is a lot easier to convert because it only uses a 4-bit number line, whereas binary has an 8-digit or bit number line, so we have to go all the way up to 128. So with hex, we only have to go up to the number 8. So we just take the nibble, if the nibble is 1010, and we convert it using our number line, 1248. And then so we have 8 and 2, 8 and 2 equals 10, so the hex digit is A, but the nibble is 1010. Now, in our MAC addresses, or physical address if we're talking from Microsoft's point of view, is burned into the NIC card, and those are burned in using hex. The first 6 hexadecimal digits are the manufacturer's ID or the manufacturer's number, and then the last 6 digits are the serial number of the card. So the first 6 are what they call the Organizational Unique Identifier, or the OUI, and that identifies the company that made the NIC card, and then the last 6 digits are the serial number of the card. And we'll talk about that more in a little bit. All right, the highest hex value you can have is 15. So if the entire hex thing is all 1, so 1111, that would equal 15. So a MAC address of all Fs would be like a broadcast as far as MAC addresses go. All right, so in order to convert, we just create the 4-digit number line, 1248, place the nibble underneath it, add the values above a number 1, and then come up with our hex value. So let's practice this. All right, now you're in store for more of my pen tablet writing terrible stuff. All right, so let's say I'm trying to figure out what 1011 is. So I make my number line 8, 4, 2, 1. I add my hex 0, 1, 1, 1. So it would be 8 plus 2 plus 1, which is what, 11. So that would be B. So B equals 1011 in hex. So a little bit easier than binary, but the exact same concept, only you only have to do the 4 digits. All right, so practice this yourself. Come up with a hex value. So let's say 1011. Is that what we did last time? I don't remember. Let's do 1110. So 1110. So we're gonna get 8 plus 4 plus 2 give us 14. And 14 is E. So E equals 1110. Let me get rid of that. 1110. Okay. So much easier than binary, but again, the exact same concept. It works in the opposite direction the exact same way. So 13 in decimal, we create a number line, place zeros underneath the ones that add up to 13. And it would be 1101. All right, so let's practice it that way. All right, so what is 12? So decimal of 12 would be 8 and 4, and then that. And that would be 12, which is C. Or if we did, let's say 10, let's say 8 and 2, and that would be A. Or we could do 11, so 8, 9, 10, 11, and that would be B. So the conversion process is the exact same. Let's say I'm looking for a 7. So then I do 0, 1, 1, 1, and that gives me 7. And if I'm looking for 5, 0, 1, 0, 1, Exact same thing. So again, your nibble can be any number between 0 and 15. All right, hex is usually given in pairs like 7C, and you just do two number lines together. So 8421, 8421, then add the nibbles underneath them. So a 7 would be 0, 1, 1, 1, and a C would be 10, 11, 12, so 1, 1, 0, 0. And then just like you convert binary, except your number line is different, and now it's just 8421, then 8421. And you don't have to do them both at the same time. You can just convert one, then convert the other one, and then kind of match them up. So let's say I'm trying to do, let's do 2B. Wow, that's a terrible B. So 2 would be 0, 0, 1, 0. And B is 11, so 8, 9, 10, 11. So 2B would be 0, 0, 1, 0, 1, 0, 1, 1. So again, just like binary, crazy easy, you only have to do a 4-digit number line. And again, you don't have to do these both at the same time. You can just do one, then write that down, and then do the other one and write that, and then just kind of combine them together. You don't have to do them together at the exact same time like I did. All right, and then just some quick notes. So hexadecimal is used for MAC addresses or physical addresses. It's kind of funny, like for some reason Cisco and Microsoft can never call something the same way. When you do a trace route on Cisco, it's trace cert in Microsoft. Cisco tends to call it a MAC address, where Microsoft calls it a physical address. All right, a hex is usually preceded by a small h or an an OX, where the O is larger than the X. So on Cisco hardware, the configuration register uses a hex value to change the loading locations. So if I change the configuration register to 0x2102, its normal operation, it would load the startup file and then make a copy of that into the RAM, call it the running configuration, and then it would load. Now, if I change the configuration register to 0x2142, that's the password recovery, where it skips the startup file and just loads a blank config. So that's where you're going to see hex used, especially like in the Cisco class. All right, then if we go to the command prompt, remember you just go to your little start box and type in CMD, get Charlie Mike David. And if we do an IP config, I don't think actually the MAC address does not show up. We need to do a MAC config /all. So IP config space /all. And now we're starting to see this physical address. So 005056C0. So here's our hexadecimal address for our NIC card. Just remember that these first 6 digits, so 005056, identifies the manufacturer of the card, and then the second set of 6 is like the serial number of the card. That way they can kind of track things down.